So I'll be talking about my journey with cars, code and AI. So just a quick disclaimer before I get into it, this quick background. What I'm going to be talking about here do not represent anything related to my employer, which is NUS, and I am definitely not sponsored by AWS to give this talk. So I just have to get this out of the way first before I continue my talk. So a little bit of background of how I got into DeepRacer and machine learning and dabbling with AI. So my background at NUS, I'm a media producer. So I'm mainly working in the education sector and I do a lot of media production and video related work. So at NUS, what they did a couple of years ago was they rolled out a competency course program for majority of the staff to upskill themselves. So this was, I think, during the pandemic, pandemic time. And one of the courses I had the chance to attend was for this AI for Everyone course, and also an AI competency course. And so this is where we were picking up skills about AI and some basic stuff about data literacy. And fast forward to sometime in August in 2023, I came across this advertisement for I think DeepRacer League that was held in conjunction with Experience IT. So Experience IT was a series of I think exhibitions and roadshows organized by the NLB in Singapore, where they were trying to raise awareness about machine learning and how this can be rolled out to more people in a more fun and exciting way, so that it's not too intimidating for them. And so this was basically what I noticed that got my attention was they had like a virtual race, which was a series of monthly races from the 1st of May until August, and the top 24 who were able to compete in a physical race. So the physical race happened I think last month in October. So they had a student category and also an open category as well. And this was what stood out to me, which was reinforcement learning. So what I learned in my AI competency course back in NUS, even though I can't say that I'm 100% an expert in AI stuff, but I still remember this was one of the keywords from back then. And this motivated me to okay, let me go try this out, because this is very familiar to me. And I wanted to see what this was all about. And because it was it involved racing cars, so I was okay, I was quite interested. And just to give a brief overview of where reinforcement learning lies in the whole artificial intelligence and machine learning spectrum. So this is a quick overview. You can see AI is the main enforcing agents, and then you have machine learning, and then within that you have the subsets of reinforcement learning, supervised learning, and unsupervised learning. But I won't be covering the others. I'm just going to be focusing on reinforcement learning. Alright, so what is DeepRacer anyway? So what you see here, right, this is the physical car itself that Amazon actually rolled out. It's not super big, it's you can hold it in your hands. It's like 1/18 scale of a race car that's fully powered by reinforcement learning. At least that's what they claim. So I was also curious to see how how good it is. And what they were saying is you basically have your car, you have your code, and you give it some time, roughly about maybe half an hour, within 30 minutes to 45 minutes, you'll be able to have a car that actually is able to navigate a track on its own. And for the more technical audience, so here's a chart from their developer website, which basically explains some of the key terms that may be familiar to you if you have looked at reinforcement learning before. If you have not, that's also fine. Basically, the car is like your agent, and it takes an action in the environment. And the environment informs the agent of whether it does something good or something bad, and it gets a proper reward according to the action states that it takes in the environment. And this drives the agent to learn and relearn skills in this reinforcement learning loop. So imagine your racetrack, this is a simplified example, that's your car, this is the finish line. And then basically imagine that your racetrack is actually segmented into a grid. And in the middle, you have your center line, and the values that you have here are arbitrary values. So let's say, for example, you only want the car to be in the center itself, so you give it a higher reward value of 2, for example. And then the ones on the sides, you don't really want the car to spend too much time on the outside of the center line, so you give it 0.2, or maybe some arbitrary low values. And then the axis and the extreme ends are you don't want the car to spend too much time on the outer lines, so you don't give it any points at all. So what happens during this whole reinforcement learning loop is that for every round the car takes to like learn and navigate the track, it will first explore. So it means the car will like try to go in like certain random patterns around the track to try to get what are the areas that the car can go to get the highest reward possible. However, after a while, the car will start to exploit the environment, which means that once it realizes the center line pays off the most for it, it will start to try different configurations to get the highest reward possible, and also to complete the track in as fastest time possible, because that's your ultimate goal. So the racetrack that I was actually looking at, because I only joined like I think late August, so this was the track that they had announced, which was part of the competition. And so I was like thinking, okay, fine, that seems fair enough. The track doesn't seem super complicated. And what you see here with the dot, with the line, that kind of indicates like which direction it's supposed to be going. And some of the races that AWS announces for these kind of events, they also have extra criteria, like they also give off-track penalties as well. So if you anyhow like make a reward function that just optimizes for speed, you just want it to go as fast as possible, you don't care about off-track penalties, right? You do have to take note of it, because these will add up, and then they will greatly affect your like leaderboard scoring in the end. Okay, so now let's get up to speed. I'll quickly walk you through like what are the steps I took to get my first working model. So basically in the console itself, everything that you're seeing here is in AWS. The first thing you do is like they'll prompt you for like a model name. So you can give it any name, any description. So basically just something that you'll be able to remember what it is once you go back to it again. And then they give you an option for like, okay, so what are the tracks? So you select the competition track for that month. And then what is the race type that you're supposed to take? For this one, it's like a time trial. So it's basically how fast you want the car to finish the track. Obviously, there are others, but I'll leave them out for now. Okay, so for the technical audience here in the room, maybe you might be familiar with some of the terms here. Of course, I am not from a coding background at all. So at this point in time, I was like thinking, okay, maybe I need to look at FAQ to like figure out what is a gradient descent patch, what is number of epochs, what is loss type, these kind of things. Because these are like very foreign and alien terms to me. But what they had advised was like if you're like first timer, like looking at this and you're thinking, okay, maybe should I spend more time tweaking this right away, or should I just move on? Actually, you can just move on. They already give you a set number of values here. You can just leave it as is. But you can always come back here and tweak it once you have your first model running. So I left those as is. The next prompt they'll ask you is, okay, now you need to give the car a set of action spaces. And they give you two options. One is a continuous action space. So over here, you have like your car, and then you have like a range of actions that you can assign to your car. So let's say over here, you have your steering angles, they prompt you. Default is like 30 and minus 30. So what this continuous action space does is, once the car learns and goes on the track, it will continue exploring and exploiting the environment and decide like, okay, it will try to figure out within this 30 to minus 30 degree steering angles, it will try to find the optimum steering angles for the track at its own time. So which means you'll need a longer training time. Whereas for a discrete continuous action space, you have more control and more granularity, but this will also come at the cost of, if you, let's say you break down the action spaces, you specifically tell the car like, these are the steering angles and the degrees and the speed at which you want the car to move at each of the different segments. Let's say, for example, in the track, there may be cases where you want the car to move faster, but because it's stuck to this, you will probably have to scrap that model again and retrain it after a number of tries. And after that, you come to the reward function part of the setup. Now, as a beginner, like looking at code and looking at like Python, so I was thinking, okay, so does that mean I have to like do this from scratch and try to figure out like what is the best output for the car to move? But luckily, they actually give you like examples, so you can make use of those. And they give you like 3 standard examples. One is follow the center line. So I have the code up here. And what was actually useful for me is like they actually comment on the code, so I can actually kind of understand like what is going on behind the scenes. So what I can gather from this is basically like they give you the input parameters for like the track width and distance from the center. They give 3 arbitrary markers with the track, and then they kind of like calculate like, okay, if the car is closer to the center line, you give it more rewards. If it's further away, you give it less. And of course, you penalize it like if it crashes or goes off course. The next one is stay within the borders, so which means the car will always try to stay within the track, and this is the reward function for that. And the third one is you want the car to drive without zigzagging across the track as well. So this is another one over here. And you have some more additional parameters as well that you can play with. And after that, actually that's about it. You already end up at a point in time where now you have your simulation video stream of the car training, and you'll also be given a reward graph to track the progress of your car. And you'll be able to see like, okay, now your car is actually training, and then it's going around the track. So once you have your car that's starting training, you will see this populate in real time. And basically you can keep track of, okay, this is the average reward that the car is like taking. That's like the green line. The blue line shows the percentage of training that's been completed. And the red line shows the percentage of evaluation that's been completed. So what happens once you start training the car, you will go through a round of like training, evaluation, and then you will record and reward for how much the car has taken before it proceeds through the following different iterations. And it will automatically pick which is the best model according to the checkpoints ingrained in the system. So you don't have to worry about like the system training, and then you suddenly like maybe somewhere down here like, oh, your training like something goes horribly wrong, and then the model it picks the worst performing model. So you don't have to worry about that. And with that, you actually already have, you would already in theory have a working model. So coming back to what I had to work with, for those people who actually sign up for AWS, right, you'll get a free tier. So they'll give you 10 free hours to actually use for training. And it's valid for like 30 days from the first time you start using it. So of course for me, I didn't have the luxury of the full 30 days because I only found out about the competition quite late. But anyway, I was still able to get something decent going. So this was my first initial run itself. I used a combination of all 3 reward functions, which means staying within the center line without zigzagging, and also staying in the lines itself. And this was about, I think, 45 minutes long. So I think you should be able to play the video. Yeah, so you can kind of see that this is where the car is going. And you'll see like, okay, like a rough timing of like how long it's actually taking. So actually I was like already quite happy with this already. I was thinking, okay, I'm done already. So now I'm like, 100% expert coder already. Actually, no, I have zero idea how this magic happened. But what I noticed at this point was like, I was excited to know more. I was interested. And as a non-coder, like this was actually quite motivating for me to go and explore further. Because otherwise, I can imagine if, like, let's say someone gets a thick stack of like reinforcement learning books to go and learn and come up with something, right? I tell you honestly, I'll switch off after I read the first chapter already because they're too mind-numbingly dry. So for me, this level of gamification that they have here in this system was very appealing. So I went back to it again. So now you see here, like the car went off track, right? It'll stop, then you get a penalty, and then it'll continue going on. So now the obvious challenge now is, okay, how do you get it going faster? And this is basically the point in time where even casual gamers who are taking part in this, as well as those who are hardcore people who are invested in this system itself, right? They take so much time just to tweak their reward function. You search online, right, and you search for like reward function DeepRacer, you'll come across a whole lot of forum posts from people trying to find out what is the best reward function to get their car running. And everyone are just so competitive and secretive about it, right? It's just kind of really funny. But it just goes to show you the extent to which these people take pride in trying to safeguard what they think is their golden recipe, right, for getting their car running faster than anyone else. But the basic steps that you would have to take, right, to improve your model, right? So let's say I just have my first model. Next one, what I have to do now is you clone the model, you adjust the reward function, you train and you evaluate, you tweak some of the hyperparameters in the console, and then you keep repeating this loop again until you end up with something that's more desirable. So it's like a very rinse and repeat kind of thing. And in this example over here, you can see that now I'm looking at additional variables like steps, progress, and then trying to put in different values to see, to incentivize the car to go faster while also staying on the track. And these are all actually provided in the developer guide in AWS, so and it's really up to participants to actually mix and match the code. So they don't really tell you outright how to go about doing it. You have to just explore and experiment on your own. And this is a snapshot of some of my submissions that I actually submitted for this virtual race. You can see I ended up, I think, submitting about like 53 times. And I ended up with like a whole bunch of like different clone models. So speaking of which, right, you can see I need to work on my naming convention because I kind of lost track after a while of trying to figure out like which model I actually clone at the start and so on. And one interesting thing I noted, right, was when you submit your models every single time, the timing actually changes, even though it's the same model. The ones here are blank because I actually deleted them because I needed space in the storage. But why this happens, right, it's like these are like the same model, but I submitted like 4 or 5 times, but I end up with different times like 11.4, 11.7, 11.5 and 12.0. This is actually very normal for reinforcement learning models, right? What happens is when you submit it, it runs through a simulation, and then the nature of the simulation is such that the results that you get are different every single time. And they kind of incentivize you to make use of this submission system. Submissions for races are usually kept at about like 50. So if you're looking at the global races, they would have a hard cap of about 50 submissions, and you would see the more hardcore contestants start pumping out multiple submissions, especially maybe 1 or 2 days before the end of the day, or sometimes at least 1 hour before. And what some of these people do is they will set up like maybe a Python script or some kind of scripting algorithm at the back end, and they will just let it auto-submit their model to the server in the hopes of getting a better time. So they are kind of like trying to game the system. So this is an example of my best model that I submitted. So this was my 48th iteration, and this was after many cumulative training sessions, so each lasting about like 45 minutes. So now you can see that it goes a bit much more faster, and it doesn't go off track. And you notice that, what I noticed was sometimes now, right, the model starts doing things that I didn't intend for it to do. Like the car starts skidding along like the corners, it starts trying to take shortcuts while staying on the track. And it's now being incentivized to pursue speed and stability over like instability and stability, which is like, it's kind of like trying to balance between how fast you want to go versus how stable you want it to be. And I'll just show you a snapshot of the competition profile itself. So unfortunately, right, the model that I had was about 35 minutes, 35 seconds. You can see that from the top 5, right, the one who ended up at #1 spot, he had like a 23.2 second timing. And then all the others are like 26.7, 28.5, 28.7, 29.0. So these are like all the, if you participate in these kind of virtual circuits, right, you'll keep seeing a bunch of these names keep coming up again and again. So you kind of know that, okay, these are like the godlike tier level people who are really invested in this. And for some of these people, right, I actually had a chance to look at some of their talks that they had given before. You might be able to find it on YouTube also. And I get the sense that they have maybe a couple of different computers at home running this like 24/7 because they have time to optimize for this stuff. So, and one cool thing about this, right, in the leaderboard, when people submit, other people can also see your snapshot of the model that you submitted. So now I've included a video of the guy who posted the first #1 timing in the leaderboard. So you can see how fast the car is like zipping around the racetrack, which is like unreal. I mean, like here I'm struggling after like 48 times, and I don't know how many times this guy did. And apparently this guy can like, he's actually one of the top racers in Singapore League. And for him, he has already qualified for the grand finals, which will be happening, I think, in Las Vegas in November this year. So he will be, in a sense, representing Singapore there, competing with other global racers as well. And this is just a snapshot from one of the prize giving sessions that he had for the people who participated in May, in like the first round of the virtual circuit organized by NLB and in conjunction with AWS as well. And this was the grand finale that happened for the Singapore leg of the virtual circuit, where they had the opportunity to actually put their models that they learned on the virtual circuit and put it in the real physical car and on a real physical track, and you see how it performs. Okay, so this is just a quick snapshot of the race itself, and you can see like they have the racetrack here, and then they have someone chasing after the car in case the car goes off track to put it back again, and this is how the car's going. And you can see they're actually holding a tablet. So what the tablet does, right, is basically like if you have your car on the track, the only thing that you can control is something like speed or acceleration. So you have like two different buttons. One is a plus and a minus, and that's it. You can't really control anything else or how fast the car is going. And this is one of the students who actually won the first prize in the student category. So it's actually quite fun. I like how they inculcated this whole community spirit within this like AWS like racing thing. I mean, if you tell people about like, okay, you go through this like X amount of hours to learn about things like reinforcement learning, machine learning and all that, right? Then I'm like thinking, okay, how could someone make this more interesting? Because for me, I'm coming from like the education side, right? I've also noticed sometimes when lecturers try to teach stuff to students, not many adopt the gamification side of things. They're actually quite few, and to come up with something like that, it takes a lot of time. But the output is that sometimes students actually find that more fun, and it's a bit more forgiving, like in terms of like, you know, you don't really feel pressure to like, oh, I need to pick up stuff really quickly. I can always go back to things again and relearn it and also have fun. And here are some more photos from like two of Singaporean racers who had won in like some of their own virtual circuits in the physical circuits a couple of months back or so. So I think they are the ones who will be in Las Vegas. So you should be able to see them pop up in the news. So what I learned, right, is basically to start simple. You don't have to overcomplicate your stuff. They have the reward functions and Python code and everything there for you. So if you are a non-coder, they'll be very easy to get things started. Training longer doesn't mean that you have a better model. Coming with the limitations that you have about 10 hours, right? Don't spend all your 10 hours on training your first model and expecting it to do wonders. So always try to segment your model training, and in about like maybe 30 to 40 minutes each, and that'll be much better. Always validate your code. So even if you think you are an expert programmer or expert coder, always double check things. Clone and iterate. That's always part of the process, and it's totally normal. Always name your models properly again. So if you end up having a whole lot of clones to manage in reinforcement learning, this will end up coming back to bite you in ways that you may not expect. So always follow a proper naming convention. Scrapping models that you've learned is actually fine, because it's better to start from scratch again than trying to rework on clone models. Because when you clone a model, right, what happens is it still retains the information that it's learned before, but something about its entropy gets affected. I don't know the exact full details of what gets affected or why, but this kind of impacts what happens to the model going forward. And they always advise you to make minor changes instead of major ones. Okay, so speaking of training, right, how much do you train, and do you overtrain or do you undertrain? And there's also a thing that's called overfitting. So for the virtual circuit, right, actually people would end up, most people end up trying to overfit their model, which means train it so much and clone it so much to the point that it performs exceptionally well on the virtual circuit. So, but when they transfer that same model to the physical track, it may not even work at all. So that means the car won't even move. And the car may move a little bit, and then it starts to crash, or it starts to do unexpected catastrophic things. So this is actually in line with another real problem that happens with reinforcement learning, which is simulation to real, where you have something that is working in a simulated environment in terms of reinforcement learning or model or code, but when transferring it to a real environment, right, you end up with different factors that may affect it. It could be things like lighting, it could be things like where things are set up, or external factors which affect it. And also the other thing is, because you have the real-time video that pops up when you're training it, you want to keep looking at it, and you know it's kind of like addictive lah, but you really don't have to. You can really go do something else when you come back again. And always keep an eye on cost. If you're training on AWS, right, it's actually kind of expensive. So you want to keep track of the AWS Cost Explorer and bidding pages. Like you have that on your dashboard, so you can always keep track of that. So don't be like this person. This was some of the contestants in the Discord. So someone said they received an email asking to be paid for like $400 for consuming cloud resources for training their model. So in case if you want to go and try the training stuff in the cloud itself, so just be mindful of that. Don't end up getting bill shock after 1 month of training. I'm happily sending a whole bunch of iterations and stuff and losing track of how much you've trained. And always do housekeeping. Do you really need to keep 50 plus models of test models in your storage? Because that will also count towards your cost as well. So speaking of rabbit holes, right? Okay, so let's say you looked at the virtual circuit stuff and all that. What other things you can do? There's a global circuits, which are challenges with global contestants across the region and the world. And there are also prizes involved as well. So if that's an incentive for you, that's cool. There's also hyperparameters as well, like entropy, the loss, and all that. There's also simulation to real, which I just talked about. And also the car itself, some enthusiasts also may also look at hacking the car to try to figure out what other things you want to do with it. And there's also like AWS Educate courses, which are sponsored by AWS. Some of these I think are free, and you can also get certification as well. The last one itself, right, local trading. This one needs its own talk itself, because all what I've covered so far, right, involves at least some element of cost after you finish using your free tier. But local training itself is actually kind of free because you are not using AWS. You can use your own offline computer to do the training. Sorry, how much time?
You said that. Don't worry.
So besides the obvious point of saving money, right, what local training offers, right, is you have access to a whole lot more of data. So this is a snapshot of what are the things you can actually look at. You have a whole bunch of charts and data analytics at your disposal to go rinse through. So this will actually give you a better idea of how to tweak your model or how to customize it such that you have a better advantage over working with limitations, I guess, within the console. Because the console is structured such that it is less intimidating. It doesn't show what is really happening in the back end to the end user. The end user just throws in a simple command and they get something working. As opposed to like local training, you have access to more things and more areas to dabble with. But this can sometimes cause unintended results, which I'll show you later. So what you're seeing here, right, with local training, they mainly, I think, make use of Jupyter notebooks, which are actually supported by the community itself. So they come up with these tools to help you. And what you see here are like different waypoints around like one of the tracks. And these numbers actually will help you try to guide you in a way such that if you're working with things like you want to do the perfect racing line, so you can make use of some of the values here in your reward function to try to incentivize the car to follow the best possible racing line around the track to get an advantage over others. And you have more scatter plots and charts as well to keep track of like reward functions and progress, and also how fast or what are the problem areas that you can kind of foresee the car is going to happen. And one other thing is with offline, with local training, you can also increase the number of CPU workers to kind of be more efficient in terms of training. So over here you can see there are 4 windows. So each of these are like 4 different CPU workers. The ones that are training on AWS console, they only assign 1 worker for your model. So for this, depending on how efficient or how powerful your local computer is, you can actually assign 4 different workers or maybe more to train the model, so it will converge faster. And convergence is key because you want it to converge faster so that you have a model that is ready to perform in a shorter amount of time. Just keep track of what happens in this bottom window below. So you'll see this one, the car is trading and something is happening down here. If you notice, all the other cars at the top three, right, they're actually trading on the track. But over here, the car has decided to implode and fly off the track for some reason. And this happens, right, this is actually shared from some of the racers in the community Slack. And they were trying to figure out what has caused this really unintentional catastrophic issue. And it turned out like they had forgot to validate their code, which I covered earlier, and they had messed around with some of the preset settings that AWS console already set for you. In local training, they kind of expose everything, so you can really go and mess with all of these settings. But if you don't know what you're doing, you may end up with something like that. And speaking of settings, right, if you're very into trying to dig into a lot of parameters and see what they try to do for you, this is an extract of some of the relevant ones for time trials that you can look at in more detail. And you can of course look at the developer guide as well. So you have things like what closest waypoints, distance from center, whether the car crashed, is left on the center line, or is off track, or is reversed. For me, I've only looked at like speed and progress, and I think maybe whether all wheels on track. For most of the other stuff, even things like steering angle, steps, track length, width, waypoints, right, they would require more time for you to be more comfortable with what they actually do, and maybe also more time in including them into your reward functions. Because training these models, right, will take time, and you need to allow some kind of buffer. You're trying to think about experimenting with this to see how best you can tweak a model to get a car moving. And speaking of cars, right, this is actually the newer version of the physical cars. The newer version itself has, I think, LiDAR sensors, so you can see like these two cameras here. And this one is more optimized for, I think they are going to be using it for like object avoidance or like racing together with other physical cars itself. So I mean, this is just extra info. But if you're interested in kind of like hacking with like physical things, right, maybe this is up your alley. So, and I think this is like the last slide already. These are a bunch of useful links that you can check out. The main thing is you can check out the global racing link at deepracing.io. They also have a very active community on GitHub and a whole bunch of tips and resources from the AWS website as well. And if you have any other things that you want to know more about, or you want to talk to me about this, yeah, just feel free to say hi. So that's about it. Thank you so much to the GeekCamp, and also this is my first GeekCamp ever. I only found out about this by happy accident because I think one of the other speakers, Hofu, because both of us are actually on the Singapore Mastodon instance, so I think GeekCamp also has an account there. They shared the post, I think he posted it, I saw it, then I ended up here. So yes, thank you guys so much for being a great audience.